How you doing? Welcome to the stream.
Hi guys, how you doing?
Welcome.
Doing great. How are you?
Thanks
great
for
to have
having me
you.
on. It's good to see you.
Looking fantastic, by the
Thank
way.
you for wearing a suit.
You know,
Thank you.
naturally, I guess when in Rome, but
Yeah.
that said, this is how everyone in Silicon Valley should dress.
I agree.
We agree. You're
Are
just
you
ahead of the
in
curve.
Silicon Valley right now? Can you give us a little
Drinking a monster.
introduction?
Drinking a monster. Let's
This
go.
is so on brand. It's amazing.
So I'm actually in my hometown of Charlotte, Vermont.
Oh,
It's where I
cool.
grew up,
Yeah.
and it's where I live.
Great.
And just got back from landed this morning from
Cool.
SF.
Nice.
How would you describe the business these days? I know that.
Well,
you've-
first we
no,
got to
please.
talk about the AI scene in Vermont.
Oh yeah.
Picking up.
You know,
Big.
yeah, I'd say that there's like one or two companies. There's a lot of I'd say independent-minded founders out here. But generally speaking, I'd say it's more of a farming.
Yeah, my little brother who's not in tech
What's it from?
went to college in Vermont and just stayed. I've tried to get him to come back forever. He's committed to the great state of Vermont. But
Well, let's introduce him to Masayoshi Son, and maybe he gets started with building an AI company out there.
it could happen.
It could happen.
It's not off the table.
So yeah, brief introduction. How would you introduce the company? How are you describing the different offerings and kind of challenges right now?
Yeah, so Lambda is an AI cloud. It's essentially really massive GPU cluster that all kinds of startups and hyperscalers use.
Yeah.
And we've both sort of invested a ton of work. It's basically around $1 billion worth of GPUs that we've deployed.
Wow.
And we've invested, at this point, probably around $100 million into the virtualization software that allows us to essentially take that massive cluster of GPUs. So you can imagine taking a cluster, let's say 16,000 GPUs, and you can sort of dynamically partition it and hand out little slices to people, on as little as a 15-minute basis. And it's quite different from, let's say, a bare metal cloud where you need to sign a 3-year contract. We've basically implemented all this virtualization software that lets you hotel on and off of it, while still, maintaining high speed InfiniBand interconnect.
You did the meme. You another $1 billion for Jensen.
Another
How many
$1 billion for Jensen.
is it actually primarily NVIDIA chips, or are there other GPU providers that are competitive at this point? I've been following George Hotz's journey with AMD. Is anything competitive with NVIDIA right now from your perspective?
I don't think that there's anything that's competitive with NVIDIA right now.
Yeah.
What you just see in the customer demand is total and utter NVIDIA supremacy.
Yeah.
And I think that this is going to continue on for some time. The test I always like to say is you've got to get a customer. They've got to be able to download kind of any arbitrary model off of Hugging Face, run that model, train the model, fine tune the model. And then they have to buy from you and then buy again. Right, so that's the test, I think, for any chip manufacturer, and it's really hard to get a stable software stack.
Do you like the term neocloud? Is that appropriate?
I think it's fine. I don't really have any opinion on it. We kind of look at ourselves as, we've always described Lambda as, what would the cloud look like if it was reinvented from the ground up for AI? Training and inferencing large language models, training and inferencing large scale neural networks.
Yeah.
And I think that neocloud's an appropriate description for that concept.
What is the balance between training and inference right now, and how has that evolved over the last couple of years?
Yeah, so we we're for the overall business, we're just a bit over $500 million of top line revenue, and I'd say that essentially,
Congratulations.
thank you. Essentially, historically, that's been majority training, and
Sure.
then sort of minority interest. Maybe 80-20 for training to inference. And now we've started to see that kind of switch over. I would generally say that when I see any sort of net new deal in the space for large scale GPU capacity, it tends to be more inference driven these days.
Sure. It's great. We're actually using the models. It's not just training ever bigger models with no. I mean, we saw that at Google I/O. Sundar Pichai pulled up the chart of tokens generated, and it's just completely up and to the right.
It's completely up and to the right. I mean, training is always going to be something where you do it once, and the whole point of training is that you want to amortize that over as many tokens as possible, right? Because that's just your fixed cost that you're wanting to spread across as many generations as possible. And so that's the point. The point of training is inference. We're there. I always kind of look at this as I always like to sort AI companies by revenue and just go, okay, well, who's at the top? Probably like OpenAI today, 4 billion, 5 billion. It's a little bit hard to, to
clock it
to exactly guess. But then, next one down, you kind of look, Anthropic, 800 million last published, mostly developer API, but probably fast growing. I would imagine they're probably in the billions now because Sonnet 3.7 was really good for code generation. Google doesn't seem to be charging, from what I can tell. But
charging me $250 a month now just to
it'll pop up to 500 too.
So they're getting my money.
What are they charging for 250?
So I am now on the Gemini Ultra plan.
Okay.
And I have 2.5 Pro preview, and then I also have access to VO3, but it's very limited. They can only generate 2 or 3 video clips per day. It's heavily throttled, but it's a $250 a month plan right now, and it's going to jump up to $500 a month in a few months. So I imagine that across Gemini Pro subscriptions, they're probably going to grow that pretty quickly, just because I'm seeing the number of 5-star reviews.
Zero to $1 billion in
100%
in a couple of weeks, right?
Absolutely.
And so when you kind of do that breakdown, what do we see in terms of like total top line revenue? It's all inference, right? I mean,
totally.
all of that is inference demand, whether it's image or chat GPT or video generation. And then, Mid Journey's probably, in the hundreds of millions of dollars revenue run rate. And so there's some substantial businesses that are being built right now. And,
what are some kind of narrative?
incumbents.
What are some narrative violations, things that you feel like the broader ecosystem is getting wrong right now, given you guys have unique insight into actual usage and activity?
Yeah. Okay. So the first one is just obviously, I think if you look back, there was that Sequoia Think Boy piece that was published on where's the AI revenue? What's
Sure.
They sort of did that. There's a lot wrong with that analysis. So I don't need to go into that, but I'd say the general pessimism of oh, it's a bubble.
Yeah.
I just remember, I started Lambda in 2012. 2013 was the year that Mark Zuckerberg went to NeurIPS and hired Jan LeCun to start Facebook AI research at the time. And I just remember everybody in the field kind of at the time looking around, oh, is it a bubble? Google's just bought DeepMind and Facebook's buying Jan LeCun. So it must be a bubble because Mark Zuckerberg just came to NeurIPS. But I think that in general, everybody underestimates what exponential growth looks like from, it always looks the same in the same, wherever you are, it always looks essentially the same. And how good the code generation has gotten over the last 90 days, right? If you were to flip back before January, state of the art for code generation was 4.0, and then 0.01 hadn't even, I think, been exactly released yet. With 0.1, 0.4, Claude Sonnet 3.5, 3.7, all this stuff, the code generation is getting so good that we, it, I think I can say here, which is in a couple of years, you're just going to have a function that goes from cache into software. And that is going to completely change the way that businesses operate, because you're going to spin up 500 different versions of the piece of software that you're searching for. You're going to be able to do this sort of like high throughput search through software space. And it's going to spit out a bunch of things. It's going to have like maybe a tastemaker model that just rates it based off of the computer use compiled version of that software. And say, hey, well, these are all the source code bases for all 500 pieces of software. These are the top 5. I'd recommend you launch this one. Go for it. And I think that's going to really change the way that the world operates in technology.
So should you learn to code if you're a teenager?
Yeah, absolutely. I think that you still need to learn how to code. I don't see. I think it's really hard to, in the intermediate period, you're still going to need to learn how to code.
Sure.
I think that you're just going to see just much higher leverage teams in the world, right?
Yeah, you might always need to think like a programmer, and so learning to code is part of that process. That makes sense. What about the evolution of chips and semis?
Before we dive into that,
sure.
I feel like there's this general thesis that sort of we've talked about this on the show, this idea of like we call it like Jiro dreams of sushi software, right? This like really craft,
more art than science.
Art and science, like super intentionally built software that is just super, super thoughtful. And you can see this in companies that like maybe go after a category like CRM, where it's like, okay, Salesforce dominates CRM, but they come in and they build this sort of really beautiful, really thoughtful experience. And typically, if the teams are good enough, they'll end up doing well. I think there's this sense that like that class of software is like safe from completely AI generated software. But in the scenario you laid out, where you generate 500 different variations of a potential tool that you'd use, and it sort of automatically ranks it based on some taste driven benchmark, is it possible that class of software is at extreme risk to disruption as well?
Yeah, well, certainly. I think anything that's just software is at extreme risk. Look at a business like Salesforce, right? It's almost as if, how important is the software? How important is the brand? How important is the distribution model? And I think that when you look, the bigger the company gets, the more important the latter becomes. The distribution model, the brand of the company, how deeply embedded it is inside of the day-to-day life of the customer that's using it. And it's sort of like, well, what is the value of Salesforce? Is it the software? No, not at all. The value of Salesforce is the fact that every single company in the world, the first thing they do when they hire a VP of sales is like make sure they have a Salesforce implementation, and then it sticks with the company until they're a S&P 500 component, and then all of the company's data is in Salesforce, right? Yeah. Does that have anything to do with the software that Salesforce has written? Is that anything? Does the moat have anything to do with the replacement cost of developing the software?
Crud app.
Yeah.
No. Right. So it's kind of interesting because like stuff like software will be solved, but then stuff like how do you build moat and how do you build a business won't be solved. So it's sort of like maybe just, this is we're in the world for just the business co-founder dominates.
Idea, the era of the ideas guy. The era of the ideas guy is upon us.
Yeah,
that's amazing.
Yeah, that would be really exciting.
Okay, I want to talk more specifically about the path to this future of like turning money into software and creating value that way. What is more important, just bigger training runs, knocking down higher MMLU numbers, benchmarks, higher IQ points versus distilling models, faster inference, cheaper inference, baking some of these models down into silicon, what we're seeing with etched and putting the transformer architecture on a chip. They seem like two different vectors. Every time a new model comes out, my reaction is always like, well, this is good enough. I just want it to be faster. And so Midjourney V6 or whatever, I'm usually just like, yeah, I just love this to be instantaneous. As soon as I type the words, it's just generating in milliseconds. At the same time, the labs seem to be iterating towards bigger and better models, and they have a mentality of like job's not finished. But what's your take on those on the trade-offs there?
Well, what we're seeing with the advent of reasoning models, as well as like the models that basically will do reasoning and then sort of like retrain the model to not do any reasoning, but sort of baking in the reasoning, is that the amount of compute that the performance improves as a function of how much runtime compute you do.
Yeah.
And so if you can make a faster model and you can reason faster about it, you can make an argument that actually might perform better in some circumstances. I think that we're going to see all dimensions of that space explored by a variety of companies. There will be people out there at the edge building the biggest frontier models. There will be people quantizing and distilling those models down to something that runs locally on your phone. That was actually kind of one of the things I did before this iteration of where Lambda is. It was sort of train convnets that ran locally on the iPhone.
Oh, wow.
And this is like 2013, and you kind of see the same thing. There's use cases for that. It's super useful. You can have privacy preserving image recognition on your phone. But it's not going to be the same quality as like something that goes back to a data center. I think actually if there's one narrative violation, just going back to, you said this like world of software generation. A lot of people are kind of stuck in this like, okay, AI is generating software. And I've got this entire, I think, thesis on where the future where we're going, you won't need any software at all, and that the neural network is going to completely replace all of the software. And so let me walk you through this. The idea is that instead of generating a program, let's say a calculator or an Excel spreadsheet, just go to ChatGPT and say, hi, please behave like a program. Please behave like this calculator or behave like this spreadsheet. Generate an ASCII user interface for me. And I want you to essentially just respond, implement the logic of that program in your mind. And that is what I call neural software. And it's really squishy. Normal software is really brittle, right? If you make a typo, you leave a keyword out, you miss a semicolon, it's not going to compile. This type of neural software, it's not really possible to have a bug. It's really more just that you've have a misunderstanding or you've misprompted it or something. And I think that that's where all of this is going. It's not code generation, but it's going to be your large language models are going to be, sort of take over more and more of program space. And you will be largely interacting with these sort of transformer models or next, token, prediction models generally, and they will be the software that you interact with.
What about diffusion models? We saw Google bring diffusion to text models. I was seeing something like 900 tokens per second. I saw a demo where someone generated a full calendar application, all the code for the calendar application in 3 seconds. It was 3,000 tokens or something like that. That feels like an algorithm from image generation that now we're seeing in the text world. Simultaneously, we're seeing images in ChatGPT maybe do something more transformer or token based. And so these lines are blurring. Can you give us any insight into what's happening there? Or is that exciting, or is this kind of just in the experimental phase?
Well, I mean, this is like, if it's whether it's exciting or not is going to kind of answer the question you had earlier, which is how successful are baked in transformer ASICs going to be, right?
Sure.
Because sort of like as the underlying space changes,
Yep.
then every one of those sort of ASICs now becomes a lot less valuable, and
Yeah.
you kind of have to go back to the more general tensor processing that you see inside of tensor cores and you see inside of the architecture of like things like TPUs.
Yeah.
And away from, really specific things that have to do with like the KV cache and different transformer specific architectural things you might want to put into an ASIC. And so I think that it's interesting to see you've got diffusion models, you've got things like Mamba, and where there's alternatives to the transformer that have what's called basically linear complexity in terms of the amount of memory that you need for the context length growing, which is better than the quadratic complexity you see inside of normal transformer models. And I think there's going to continue to be a lot of innovation in the model architecture space, and that will probably benefit NVIDIA a lot.
Got it. Are there any other side projects in semiconductors that are exciting to you? Huge wafer scale computing like Cerebrus. We talked a little bit about baking things down onto ASICs. We saw that path play out with Bitcoin, with the FPGAs, and then the ASIC kind of Bitcoin mining. There's other approaches, and I'm sure NVIDIA is not asleep at the wheel. Jensen Huang's in founder mode. He's aware of the boom. He's aware of the demand. I'm sure people are asking him, how can we run diffusion models faster? How can we run transformer models faster? What are you expecting on the semiconductor side over the next few years?
Well, it's pretty clear that I'd say the front runners for competing with NVIDIA, which are all very far behind NVIDIA, but the ones that are sort of, I think, the farthest along is probably, I would say today, is Google and to some extent Amazon with Trainium and Inferentia.
Yeah.
That space is always evolving fast, but I think it's kind of a little bit telling that AMD hasn't, with all the resources, with all the sort of clarity on what you're supposed to build for the market, hasn't been able to kind of capture enough market share.
Dylan Patel's going to turn it around. He's going to write just one more report, and AMD is going to be back. I'm bullish.
That's all it takes. All it takes.
I love it. But in terms of, can you give us a little perspective on obviously if I'm doing a ton of inference on Lambda, I'm probably in the CUDA ecosystem, probably in NVIDIA land. If I want to take that over to Amazon or Google with TPUs, how much of a barrier really is that? Can you kind of explain? Because at the same time, we have these incredible code generation models. It feels like putting an AI agent on rewrite this CUDA for TPU, that seems like the easiest thing to do.
Yeah.
It seems like a problem perfectly tailor-made for AI agents to just sit there and write boring translation code. It's not even feature design, right?
Wasn't that in the TL where someone was making a joke about the Anthropic safety snitching on the user, and someone said, port this PyTorch code over to JAX, and then it says, searching, calling FBI.
Calling
hotline.
FBI, do not do this. You're gonna pull the rug on the entire economy. If you do
preserving the underlying chips that it's running on.
It's so important to America.
So I think that okay, the stuff that this code generation is really good at today is still sort of what I would call within the realm of what, one-shotting a basic program, one-shotting sort of a one-page program, or it could be much longer than one page, but it's sort of like single file.
Yeah, or a function, or a class, something like that. Not necessarily something
maybe I'm just behind on it a little bit, and I'm not, doing what the kids are doing or something with sort of an AI IDE, but I just kind of like when I'm vibe coding, I will just tell either ChatGPT or Gemini or Claude, I'll go do this in one page, like have it be a one thing. I want to copy and paste this into my thing and run it. And it's quite good at that. Now, when you talk about like going through an entire code base, fixing the compilation errors, because there will be like subtle bugs that get introduced, it's not quite there yet.
Yeah.
It's just the problem is that I now am at like 100% confidence that it is going to be there in just a couple of years. And that's kind of why I know that every sort of megawatt that we build and every GPU that we deploy is just going to get met with demand on the other side, because just 2 years out, like if you just look 2 years ago, 2023, code generation was primitive.
Yeah.
Primitive. It didn't work. Now today it really works for more simple programs. I think 2 years from now, it's just gonna make you feel sick when you look at it.
So what are the big bottlenecks you foresee between like energy, water, land? Are you going to be building the data center in space? What do you think in the future looks like for you?
So I think that the bottleneck is definitely what I call like wrapped power. So I think there's plenty of generated power. Right now, it's just not wrapped up in a data center shell. It's not in a powered shell. It's not in a facility that has direct-to-chip liquid cooling integrated into it. And so it's sort of like that wrapped up power that's like ready for the current generation and next generation of chips. I think that there's definitely some like regulatory bottlenecks, or I would just say regulatory hurdles that can be removed. And I think there's a lot of hope that this administration is going to start to remove those. That's like, whether it's like looking at sort of the way that we run utilities, where you kind of have to, in some cases, become an unregulated utility and put like, let's say, build a data center power plant, which is to say behind the grid or not attached to the grid, power generation station next to a data center. And not every state's going to allow that. And I think that there's probably a lot to do in the regulatory side to unleash the free market and let people build. And so I think that I think there's some hope there. And the other thing is just really, I think, building large contiguous spaces is pretty clearly the answer, in my opinion.
Well, good luck with that. I'm glad I don't have to deal with it.
But it's a lot of logistics. It's a real pain.
Yeah, it sounds like a lot of work, but you've been doing it for 14, 13 years.
Yeah,
so
classic
I'm sure you got
overnight
another
success.
decade in you at least. So good luck to you.
Yeah,
we'd love to have you back on. This was a fantastic
come back
conversation.
on again soon.
Thanks, guys.
So many fun.
Love what you
angles.
do. Long time fan.
This
I
is really
didn't
awesome.
clock you as a monster guy too. We got to go deeper on energy drinks.
Yeah,
next
there's so
time.
much to talk about.
Lots to talk about.
But this is fantastic.
You're the
Thank
man.
you so much
All
for
right.
coming on.
Take
We'll talk
care,
to you
guys.
Great
soon.
chatting.
Peace.
Cheers.